All right, so this is example number 2. Here is an illustration of how green infrastructure, in this case detention pond, can reduce the contaminant loading to a stream. So if you read the examples, it says that the stream is polluted with the contaminants at concentration 6 milligram per liter. So let's think this is our stream. It's polluted at a concentration of pollutants at 6 C in is 6 milligram per liter. It is discharged into something else where the TMDR limit is 1 milligram per liter. So the desired output, what we're supposed to have is 1 milligram per liter, but it's not, it's 6 milligram per liter. You are asked to reduce the concentrations, concentration to meet the TMDR requirement. That's why I write C out equal to 1 milligram per liter. To do so, you can build a detention pond with a volume V where the contaminant can degrade at a rate of K equal to 0.01 per day. So what essentially you can do is create this pond over here so that it reacts some of the pollutant that we only discharge at concentration 1 milligram per liters. And it says this volume is V, and that's given over here. Actually, it's not given. That's the question. What's the volume of the pond so that it can reduce the contaminant concentrations to 1 milligram per liters? But you know the K, which is 0.01 over day. So first, anytime the K unit is 1 over time, that's a first order reactions. Because if you see the first order reaction, the way it is written is K over C. So that means C cancel as far as unit is concerned. So the K unit is 1 over time. So because the K is 0.01 over day, then we can assume this is a first order reactions. So we can say this is first order. And then also if given this is a steady state. Steady state. And also there is no evaporations. That means there is no mass loss. So now you have to solve for volume. Well, if you write the equations, mass balance equation, B dC over dt in a system would be Q in, C in minus Q out, C out, plus the pond reaction rate. So that will be, all right, plus volume time reaction, which is first order reactions, Kc. The reason I write negative is because this is a reaction that decreases the concentrations. And you know that it's a steady state, so that will be 0. So if you write that equation, so that will be Q in, C in minus Q out. As you know that the pond, if it's a steady state, that means the volume doesn't change. So that means you can write the amount of flow coming in has to be amount of flow out, so that we can write Q out equal to same as Q. So you can say Q in, Q out, Q, because it's a steady state. There is no accumulation of water in the pond. So I can write this one as Q. Then C out, again, same thing. We can say that C out is same as C in the pond, same as C. Then this is minus V Kc. In fact, this is the same equation we derived in few slides ago. Then you can write the final equation if you know that number. So that will be C is C in divided by 1 plus P over Q K. And if you have this equation handy, then you can just directly write and writing the assumptions. So C in is 6 milligram per liter 1 plus volume. Well, we don't know the volume, so we can write the volume here divided by Q. Q is somewhere here, so that's 100 meter Q per day. And then the rate of reactions is 0.01 day over day. So now you have one issues here. This is meter Q, this is liter. So that means you have to change meter Q to liters. So to do so, you know that 1 meter Q will be 1000 liter. So if you write that equations over here, so that will be, and then C is same as, C is 1 milligram per liter is 6 milligram per liter divided by 1 plus V. Then you have 1000 here, 100 meter cube. Then you can write that will be V divided by 100,000 times 0.01. That would be meter cube cancel, so that will be day cancel. So that's liter. So if you solve for this equation, you can finally solve for L. Or if another way, if you arrange this equation from here, what is L, then you could write, I'm sorry, what is V? Then you can write V equal to QCN minus QC divided by KC. So you could write all that value over here and solve for V directly. Anyway, so you know how to solve it. Again, the point here is you have to recognize what equation to use. And in exams, I'll ask you to write the mass balance equations, at least write in the form so that you understand the reason what that equation is. Then you can say that without solving, this is the mass balance equation, this is the final form over here, and then that solution would be this.